Section 14.2, we're going to be multiplying and dividing rational expressions. I'm going to break this up into two parts, multiplying and dividing. I'll show you how to do both. So when multiplying rational expressions, we factor completely, cancel common factors in the numerator and denominator. And then multiply across. When I say multiply across, I mean like this. There is something called cross multiplication, and that's different. That's if you're solving a proportion. We're going to factor completely, cancel common factors, and then multiply across. And I'll show you a few examples of those. I'm just going to ask you to simplify. Say we had 6x over y squared times 3y over 5x. Now there's nothing to factor. We could just multiply straight across and get 18xy divided by 5xy squared. Now, earlier in the course, we talked about properties of exponents. And we said when you're dividing, like x to the first divided by x to the first, what do we do with those powers? Subtract them, right? So 1 minus 1 is x to the 0, which is just 1. Anything to the 0 power is 1. In other words, these cancel. Y to the first divided by y to the second is y to the negative first. Remember, we're going back to a couple formulas. We know that if we're dividing the same powers, you subtract them. We also know anything to the 0 power is 1. And we also know that when you have a negative exponent, this means the reciprocal property. So the answer for this is just going to be 18 over 5y. It's on top, 5's on the bottom. And if it's y to the negative first power, that means y is also on the bottom. So the 18/5 is its own thing. So 18/5 doesn't have negative power, so it's just 18/5. Another way to think about this is 18 over 5 times y to the negative first. So whenever you divide y to the first divided by y to the second, whatever that answer is, that's always on top. So y to the negative first is on top. But we don't want it to be negative, so we put it on the bottom. Does that make sense? So this just becomes 18 over 5y, like we said. All right, maybe see a couple more of these. What if we had x over 3x minus 6 times x squared minus 2x over 7. Remember what we said the first step was to factor. So we could actually factor the bottom here. We can take out a 3. You take out an x on top. And now that it's factored, we can cancel out common factors. We have an x minus 2 on top and bottom. And then just multiply across. X squared over 21 would be the answer. One more of these, and then we'll take a look at division. Here, we'll do a fun one. How about x squared plus 14x plus 48 divided by x squared plus 3x minus 28 times x squared minus 3x minus 4 divided by x squared plus 6x minus 16. Really, for this problem, it's just a big factor problem. We have to factor 4 trinomials. We've been factoring trinomials for a long time, so I'll just show you what the factored form is, and then we'll talk about how it simplifies. This top is going to factor to be x. Let's see here. Numbers that go into 48 and add up to 14. What would that be? 6 and 8. Thank you. That's right. And so 6 and 8. So this would factor to just be x plus 6 times x plus 8. I think in the other class, Dean asked, if the leading coefficient is 1, can't you just write it with parentheses like this? And the answer is yes. So we could do it the long factoring way, but also if this leading coefficient is 1, you could just put the 2 magic numbers right here. It's a little faster. You could always do it the long way. You can't use the shortcut if the leading term is something other than 1. For the second one, numbers that multiply to be negative 38 and add up to be 3. What's that? Negative 28. So what would that be? You have 28. 14 and 2 wouldn't do it. 4 and 7. So if we use positive 7 and negative 4, that'll work. This one we could use negative 4 and positive 1. And then this one we could use positive 10 and, or let's see, positive 8 and negative 2. Once you get them completely factored, it's kind of fun finishing it. You can just cancel the common factors. So x plus 8's cancel, the x minus 4's cancel. And it looks like we're just left with x plus 6 times x plus 1, all divided by x plus 7 times x minus 2. And then the last thing for this section is we'll talk about dividing. So when dividing, rational expressions, we factor completely. The difference is we multiply by what's called the reciprocal. Cancel common factors. And then multiply. And we multiply across. So we'll just do a few examples of these here to wrap up this section. When we talk about reciprocal, reciprocal means you switch the top and bottom. So if I asked you what's 5 divided by 1/2, the reciprocal would mean you multiply by 2/1, which would be 10. And so that's what reciprocal means. We'll just do a few of these. What if I asked you just to divide? And we had 5y to the 4th divided by 3y to the 5th divided by 10y over 15y to the 3rd. So there's nothing to factor here. We could just go right into multiplying by the reciprocal. Five times 15 is 75, y to the 7th. And the bottom would be 30, y to the 6th. And then simplifying this further, 75 over 30, we could take a 5 out of the top and the bottom. Actually, we could take a 15 out of the top and bottom. And the top would just turn into 5 over 2. And 7 minus 6 is y to the 1st. Remember, whenever you do that division, whatever answer you get goes on top. And then if it's a negative power, you would put that on the bottom. Couple more. What about if we had u squared minus v squared over u minus v divided by u over u squared minus v. Just like before, we want to make sure we factor completely. This upper left expression is a difference of perfect squares. So we're going to write u plus v times u minus v over u minus v divided by u over, we could take out a u on the bottom and we just get u minus v. So the symbols are a little tricky, but you could factor a perfect a difference of perfect squares upper left. We could factor out a GCF bottom right. And now to finish, let's multiply by the reciprocal. And we're going to cancel common factors. It looks like we're just left with u plus v times u minus v. Then I'll show you one more example to wrap up tonight. What if we had a problem where it's, let's say, x squared plus 8x plus 12 divided by x minus 7. And then we're going to divide that by x squared minus 6x minus 16 divided by x minus 7. First thing we do is we could factor. The top is going to factor to be, what is this, x plus, thank you, x plus 6 and x plus 2. And the bottom is just x minus 7. We're going to be dividing by, this will be x minus 8 and x plus 2 over x minus 7. Then we can multiply by the reciprocal here. This will just be x plus 6 times x plus 2 over x minus 7 times x minus 7 over x minus 8 times x plus 2. Then just look to cancel the same factors. So it looks like the x plus 2's cancel, the x minus 7's cancel, and we're just left with x plus 6 over x minus 8.